Hello, the topic for today is approximating rational numbers on a number line. So we're going to be approximating and placing numbers on a number line. So before we begin, I want to remind you that there's a formative assessment Wednesday over everything we've done in this unit. So irrational, rational numbers, repeating decimals, and approximating. And we have a summative plan for Friday. You're going to have to remember to sign up with me because we don't have regular sessions on Friday. Also, I've noticed that many of you are not checking your answers with my answer key to see if you are doing the problems correctly. You won't know if you understand the concept if you do all of the work, but you're doing it wrong and you don't know it. So don't waste your time. Make sure you're using my answer key to see if you're doing the problems correctly. This falls under the habit of mind striving for accuracy. If you don't know how to do the problems on the assignment and don't learn from your mistakes, you're not going to do well on the assessment. So strive for accuracy. Make it a priority to check your work and correct your mistakes. And also, there are some of you that are falling behind with the daily work. I am here in the classroom all the time. I can sit with you to do the homework, but make sure you're keeping up. All right, so let's start simple. We are going to be placing numbers on the number line, but we'll start with some easy numbers. To place a number on the number line, you find this place on the number line where the number is located, and you put a closed circle. And I'm going to write the number right above it just so I know that I put a number there. -2. Here are my negative numbers. -2, 5. But sometimes you have to do a little bit of work. 6 divided by 3, or 6/3, can be simplified to 2. If you have to do something like this, if you have to change the number to find the location, please show me what you are doing. That's part of justifying. So here is 6/3. And then the last one is -4.5. So we go all the way to -4, but we have to go halfway more. So right there. So I'm going to put a closed circle and -4.5. Pretty easy, right? All right, let's try the second problem. This case, there are repeating decimals or not ending decimals, so you might have to do some rounding. So you're going to approximate these by rounding probably to the nearest tenth. So here is the tenth. I'm going to look at the hundredth spot. It is not more than 5, so I'm going to leave it 3.3. I'm going to go to the tenths. Round up because it is the hundredths is a 5, so -2.5. And here's the tenths. Look at the hundredths. It's not greater than 5, so I'm going to leave it 0.5. And now I can place these numbers easily. 3.3. Here's 3. You know that halfway in between is a 0.5, so it's going to be a little bit less than that. So it's going to be about right here. So again, you're approximating, but what I'm going to be looking for is it in the right spot compared to the whole numbers and that halfway mark. So this is 3.3 repeating. -2.5, go to -2 and halfway. It's about right there. -2.45 repeating. And 0.5. So between the 0 and the 1, 0.52345. So again, what we did was we rounded to the nearest tenth. Alright, so with this next problem, we have some that are easy and some that are not. So we have a little bit of work to do, and you have to justify. So in other words, change fractions to decimals and round to the nearest tenth, or think about what two numbers it's between. So the 1/4, we know that 1/4, if this part is 1/2 right there, 1/4 is right there. So 1/4. negative 3.2. So negative 3 is there. We have to go, if this is 1/2, 0.2 is going to be a little bit closer to negative 3. So right here. And instead of putting the number above, now we have letters that we can. So instead of putting 1/4, I'm going to put an A. Instead of putting negative 3.2, I'm going to put a B. 6/7. We could certainly change that into a decimal. You should know how to do that. But a real easy way to get it on the number line is 6/7. 7/7, you know, is 1 whole. So it has to go a little bit before that 1. So right there, approximately. And 1.67 repeating can be rounded to 1.7. So approximately right there, D. Again, I knew that it was a little bit closer to 2 because 0.7 is greater than 0.5, and 0.5 would be right in between. All right, up to this point, we've only worked with rational numbers, approximating rational numbers on the number line. But we need to start talking about irrational numbers too. So before we do that, I thought it would be beneficial to remind you what perfect squares are. To find perfect squares, we take numbers, we take a number, multiply it by itself to equal that perfect square. So a perfect square has 2 factors that are the same. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25, etc., etc. So you might, while you're working on this next part, have a list of perfect squares in front of you, because what we're going to be doing is finding which 2 perfect squares a number is between. So 81, 100, 11 times 11 is 121, 12 times 12 is 144, 13 times 13 is 169, 14 times 14, 196, 15 times 15 is 225, and I think that's as many as you need. All right, there's certain steps to approximating square roots, and I know those of you that are not fans of math are going to be grumbling because you have to actually do some multiplication. This is a no calculator unit, but we're going to try to make it easy. So we're going to approximate the square root of 14. So the first thing you need to do is think, okay, which 2 perfect squares is it between? We have the perfect square of 16 on one side and 9 on the other. So if you look at that list, 14 falls between those 2 perfect squares. And this is important because that means that the number, when multiplied by itself, is going to give you 14. And that number has to be between 3 and 4. 4 times 4 is 16, so that would be too much. But 3 times 3 is 9, and that would be too little. So we know that the square root of 14 is between 3 and 4. Now I want to remind you, we'll never find it exactly because it is an irrational number. This, if you plug it into a calculator, it's going to give you a decimal, but in reality that decimal will go on and on and on and on and on, just like pi. So we know that it's between 3 and 4. So we know that my first guess is going to be 3 point something. Now this is where making a wise decision will really pay off. You have to look, okay, which one is it closest to? 14 is 5 away from 9, but only 2 away from 16. So we know that it's going to be closer to the 4. So we are going to make a guess that is closer to 4 than to 3. So we're not going to guess 3.5. Now it's 5 and 2, so I think my first guess is going to be 3.7. And I'm going to check to see how close I am by doing the multiplication. So when I do the multiplication, 7 times 7 is 49. Carry the 4. 7 times 3 is 21, plus 4 is 25. And then I have to keep my place value. 3 times 7 is 21. Carry the 2. 3 times 3 is 9, plus 2 is 11, and I'm going to add down, and there are 2 places after the decimals in the problem, so there's going to be 2 in the problem there. So 13.69. 13.69 is less than 14. So I'm wondering if I can get closer if I make another guess. So you do have to make 2 guesses for each problem. So if 13.7 is too little, my next guess is going to be 3.8. I think I said 13. 3.7 is too small. 3.8 might be closer. So again, I'm going to do that multiplication. 8 times 8 is 64. Carry the 6. 8 times 3 is 24, plus 6 is 30. 3 times 8 is 24. Carry the 2. 3 times 3 is 9, plus 2 is 11. I'm going to add down, and I'm running out of room. 4, 4, oops, 1. So now I have 14.44. So we know it is somewhere between 3.7 and 3.8, but we have to give an answer. So we need to see which one is closest. We're looking for 14. That's what we're looking for. When we did 3.8, it was 44 100ths away from 14. And here, 0.69, if we added 0.31, it would get us to 14. So our first guess of 13.69, I'm sorry, our first guess of 3.7 was the closest guess. So a big mistake that is made is putting this as my answer, 13.69. It is not. It's what we multiplied by. So my answer for the square root of 14 is approximately 3.7. So again, what we did is we found the 2 perfect squares that the square root of 14 was between. So this right here, we looked, we saw that 14 is between 9 and 16. Therefore, the square root of 14 is between 3 and 4. Because 14 is close to 16, we picked a decimal that was larger than 0.5, and then we did the multiplication to check to see which one is closer. Alright, let's do another one like this. I know this video is getting lengthy, but I feel like you should probably have at least 2 examples. Alright, the square root of 30. If we look at our list, it is between the perfect squares of 36, which is too high, and 25. So 30 falls between 25 and 36. So we know that the approximation of the square root of 30 is between 5 and 6. So what we're going to do is look to see which one it's closest to. It's 6 away from here, 5 away from here. So it is almost smack dab in the middle, but it is closer to 5. So we're going to try the first guess of something that is closer to 5. I'm going to guess 5.4. It might be 5.5. It is right smack in the middle, but I'm going to try 5.4 first. So we are going to see how close 5.4 is as the approximation. Now remember, it's not exactly 5.4. It won't be exactly 30. We're trying to get close to 30. So 4 times 4 is 16. 21. 5 times 4 is 20. 5 times 5 is 25. Carry the 2, so 27. I'm going to add down. 29.16. 29.16 is approximately 30, but can we get closer? So now I'm going to do my second guess. Since this is smaller than 30, I'm going to guess 1 decimal place higher, so 5.5. And again, I know that for those of you that don't like math, this is a pain to do this multiplication, but you won't have to do it for long. 5 times 5 is 25. Carry the 2. 5 times 5 is 25 plus 2 is 27. 0 placeholder. 5 times 5 is 25. Carry the 2. 5 times 5 plus 2 is 27. Add down. put in your decimal place because there's 2 here, so there's going to be 2 here, 30.25. I can see 30.25 is only 25 hundredths away. This answer is much further. So I'm going to use this one. And remember, it's not what we get when we multiply. That's how we're checking our work. It's what we multiplied. So I'm going to say the square root of 30 is approximately 5.5. So some of your assignment today is just approximating, but our real goal is to approximate to help us put numbers on the number line. So we're going to do like we did before, but we do have 2 that we need to estimate. So 1/2 A, 1/2 is 0.5, so that one's pretty easy, 0.5. And 2/7, we know that it is going to be less than 1, but greater than 0, so we know it's going to be in this area right here. 2/7 is less than half because it would 3.5 is half of 7, so I know it's going to be less than half, so I know it's going to be going on this side of A because A was 1/2. So they're very close together. All right. So when you're placing it on a number line, you don't actually have to do that multiplication because it's estimating, but you do have to do the initial first steps. The square root of 17 is between the square root of 16 and the square root of 25. So we know it's going to be between 4 and 5, so 4 point something. It is very close to 16, so it is going to be much closer to the 4 than to the 5. So about right here. And because we're estimating, if you graphed a 4.1 or a 4.2 or a 4.3, they're going to be in about the same place. So I'm going to put it right there. And then this one, the square root of 24, is between the perfect squares of 25 and 16, but it's very close to this one. So we knew it was going to be between 4 and 5, so 4 point something, but now it's going to be much closer to the 5, so it's going to be about right there. And how I have this, everything that I've written up here, this is your justification. So when I say justification, I'm just saying, tell me your thought process. All right? And that's all you have to do for your assignment today.